All right, hey everyone, Riley here from becominganelectrician.com. In this video, I'm going to be talking to you about a roughing in material list. Okay, this is going to be for more of a residential setting, and hopefully it's going to help you out. The biggest thing that you need to understand is there's two places you need to look for when it comes to material that you're going to need. The first thing is your panel schedule. Okay, so this was a suite panel schedule when I was working in the field, and this is for a condo. Okay, so for a home, maybe you're going to need some more circuits, but this is a typical layout in like a condo suite. So look at the panel schedule to figure out your circuits. That's what we call our home runs. Okay, and then we have our prints. So for example, this would be like a bedroom, and what you want to do is you want to go and you want to count each device to figure out the amount of boxes that you're going to need, as well as it'll give you an idea of how much wire you're going to need. Because what happens is, let's say this one is the home run. Okay, so what we do is from the actual panel, we run a home run to this, let's say, plug, and then each of these is what's called branch circuitry. Okay, so we need to run jumpers to them to continue power off of this home run. Okay, we're going to break all that down in this video, but again, if you want to stay updated with this website, becominganelectrician.com, check out my free book I have for Apprentice Electricians. Okay, you just go to becominganelectrician.com/subscribe, and you guys can get my free book. There's tons of valuable advice that, you know, when I was an apprentice and I went through all that stuff, the school, being taught by journeymen, tons of valuable tips in that free book for you. Okay, so like I said, the first thing you want to do is when you just have a home, and I'm going to be talking more as an electrician, not so much a homeowner, but if you are a homeowner, building your very first home and you're trying to do it yourself or save cost, hopefully this is going to help you out, okay? So when we are electricians in the field, we are given a set of prints, and we have many prints to look at. And if you can learn the prints as an apprentice electrician, you are very valuable because you know what the job requires. Okay, so on a job site, we have a couple set of prints that we need to look at. One is the actual main panel schedule, okay? And that is essentially just lights, general plugs, and let me just kind of zoom in, okay? So a range is like your oven, a condensing unit is like your air conditioner, okay? So there's different words to say it depending on the engineer you're working with. Your dryer is like your clothes dryer. You can see that they actually take up 2 circuits, okay? So when it comes to a panel schedule, what you need to be looking at is you need to be looking at, these ones they just take a single circuit. So circuit 1, circuit 2, or circuit 3, but it's all just a single circuit, all right? And so that requires just a single circuit breaker, and they're really, really simple, okay? So circuit breakers are starting to change a little bit. Now most things are becoming arc fault protected, so this type of breaker isn't probably what you're going to need for most of these circuits. A lot of these circuits are what's called arc fault protected now. So this is like a standard breaker. It does not have the arc fault protection. So again, you have to look at your prints, what they're asking for. But all you do is you just loosen this screw, you put the hot into there, and the neutral would be tying into the panel. But if it's an arc fault breaker, the setup is a little bit different. But this is a single circuit. So as you can see right here, we have lights for circuit 1. So how a panel works is it goes 1, 2, 3, 4. And how it actually works is, so if we just do this, so lights 1, and so circuit 1 and circuit 2 is actually A phase. When we go to 3 and 4, it's B phase. If it was a 3-phase panel, 5 and 6 would be C phase. But if it's just a home, then 5 and 6 goes back to A, 7 and 8 goes back to B. And so in other words, when we're talking about sharing neutrals, that's how that works. So you cannot share a neutral between 1 and 2 because it's the same phase. If you want to share a neutral between 1 and 3, you can do that. Same with 5 and 7, you can do that because they're different phases, okay? So let's talk about over here now, okay? So we have 2 circuits. That is your oven. And you can see that would require 2 circuits. So it would be A phase and B phase in a typical home. Okay, most homes there's only 2 phases. You can also see this is special because this breaker has what's called a tie bar. This is code. So in other words, if one circuit gets overloaded in this oven, then the whole thing would trip. So it's on. So imagine, so how it works is it goes into your panel, kind of hooks in, and then these are like the teeth which actually connect and give you your power. And then this is just like the switch. So if it's off, there's no connection right here. There's no connection right here. And if it's on, then this closes. And let's see if we can even see that. No, okay. Oh yeah, it moved a little bit, but you can see that it has two, okay? So in other words, so you're gonna have to go through this list and you have to count all your breakers. This is probably gonna be one of your most expensive things in the job if you are buying your own material. As electricians, we just get it from our company, right? So it's a matter of just looking at this panel schedule, seeing that, okay, well, we need one 20 amp circuit, another 20 amp circuit, okay? So stuff like that. We have a whole bunch of 15 amp circuits. Again, you have to be looking, is it arc fault protected? That's a new code thing coming out. And then also you have to look at how many 2 gangs do you need, and then also the size of that breaker. So I haven't put the size of the breaker for the baseboard heater, but if it's number 12, typically it's going to be like a 20 amp breaker. Dryer, this would be like a 30 amp breaker. You can see here we have like a 50 amp breaker. Okay, so that is just your panel schedule. Okay, now when it comes to our other prints, let's just quickly look at that, because this is what also a part of roughing in. So again, typically on a job site, you are given a set of prints. The prints would lay out each floor. Now this is just like a single room on one of the floors, okay? So for example, let's say we're talking about a 3-story house where there's an upstairs, your main floor, and then a basement. The prints would typically have a different page for each floor. Okay, and then on that floor, it's actually listing out all the different devices. You can see this is the symbol for a single switch. We have just a basic plug, a 15 amp plug. This right here would be like data. So it could be like internet, telephone, or cable. Okay, so coax. So everything is, kind of depends on the building. But what you want to do is you want to go around and you want to figure out how many boxes do you need? And what I mean by boxes is you can see that I have, this is just called like a single gang box. All right. Now, if it has to go on the outside wall, this is called a vapor barrier box. This goes on the outside of the wall. So what happens is the insulation poly, okay, so like they will actually put the insulation in the walls, and then they're going to put a plastic sheet. It's called poly, that's just what they call it. And they will tape it around here to keep the vapor barrier on the outside of your home, okay? So that's kind of like an outside wall plug. You only want to really use these on the outside walls because they're expensive, okay? Something like this, let's just say is $1, okay? Something like this could be like $2.50 or something. So it can really increase your cost, because if you have like 30, 40 plugs in your home, that could save you like $100 kind of thing, right? So this is just a single gang plug, okay? Now, another thing to look out for is sometimes depending on the room, like let's say you're in a more higher end home and you have a whole bunch of switches, like let's say there was 3 switches here, that's an indicator that you have a 3 gang box, okay? And then when it comes to code rules, you just got to know a couple certain things about these kind of boxes. So you screw them in, but when you have 3 or more devices in a box, you need to support it on 2 sides. All right. And so that's it. That's it when it comes to kind of roughing in. So you go around, you count all your boxes. You're going to have to figure out the different types of wires. And I guess that's the thing we will talk about next. I also have some other things that you may have to look into. But you just need to essentially look at this panel schedule. By looking at this panel schedule, it's going to tell you the wire size. Okay. For example, if it's a 15 amp breaker, it's typically telling us that we need, so this is like 14.2, okay? This is going to be your most common wire in your home. Now, first of all, this is just your home run, okay? So when I say home run, that is coming from the panel, so wherever the panel is, to the first device, okay? And then from the first device, then you have to run your what's called jumpers, okay? And that's called branch circuitry. So we have our home run and we have branch circuitry. So this would come from the panel to power the very first device, and then we also need to run this same wire to the other devices to continue on power, and then we just make a splice in each box. So you're gonna have to figure out how much of this wire are you going to need, okay? And again, you are gonna reference off of this panel schedule how much 14.2. Okay, so this is 14.2. Some other things are like kitchen counter plugs, and that's where you're going to need 12.2. Okay, so it's a bigger gauge of wire, which means that it applies to your kitchen counter plugs, which is a 20 amp circuit. Generally, what we are focused on, like the whole reason you have this panel schedule and the different sizes of breakers, is for heat. Okay, so wires, depending on how much current is going through them, it heats up. Okay, and it's all about protecting the wire. So if the wire gets too hot, that circuit breaker, the whole goal of this breaker is to trip. Okay, it's about protection. Otherwise, what will happen is this wire can keep getting super, super hot and start a fire. And that's the whole point of the breaker. It's called overcurrent protection, okay? So you look off of the panel schedule, it's going to tell you all your different devices, things such as like dishwashers, your clothes dryer. If you have a home where, let's say they have a rental suite in the basement, there might be 2 clothes dryers, or there might be like 2 washers, or stuff like that. So that's where you look at this, and it's your first sign of material, okay? And then sometimes, depending on the actual piece of equipment, sometimes it could be a 10.2, let's just say. So this is a number 10, which means that it can have more amps. A number 10 is, at the moment, it's rated up to 30 amps. The thing with electrical is things change all the time. But generally, your number 10 could be a 10.3 or a 10.2. So when you hear 10, that's the size of the conductor, okay? The 2 is how many insulated conductors, okay? You're always going to have a bond wire in there, okay? If you see really close, so in the middle, there is a conductor. Then you have an insulated conductor on the left, insulated conductor on the right, so a black wire and a white wire. So this is a 10.2 because we don't count the bond wire as a conductor, okay? It's just a bond wire for safety. We connect it to the metal components of the device so that it can never be energized, okay? But this is a 10.2. But typically in a dryer, you would need 3 conductors. Now, again, this is 12, so this is not 10. But sometimes you might need 3 conductors. And as you can see, let's move that a little bit. So you can see there is a black conductor in there on the right here. There's a white conductor and a red conductor. And then there's also that bond conductor. Okay, you're always going to have that bond. The bond's right there. There's the red. The white's at the bottom, and on the far right is the black. Okay, so this is a 12.2. Let's rip that off. Now, when it comes to our dryers and our ovens, typically we are running 3 conductors, but it'd be a bigger wire size, like an 8.3 or a 10.3. Okay, I just wanted to show you. So depending on the actual device that you're running, you have to know how many conductors and the wire size required, okay? And how you're going to figure that out is, again, first of all, you look at the actual panel schedule, okay? If there is 2 slots taken up, typically it's going to be 2 wires needed, all right? Once you're into the 3-phase world, it would be like 2, 4, and 6. And then now you know that you're going to need at least 3 wires. But the biggest thing you have to understand is, does that piece of equipment, does it need a neutral? Okay, and then where you go for that is typically in the commercial world of electrical, we look at what's called like an equipment schedule, and it will break down the voltage, the number of phases, and very often like what you're going to need for wires. As you can see, like an 8.3, and Cu means like copper. Sometimes there's aluminum to save money and stuff like that, okay? I'm not going to cover that too much in this video. Now, one final thing I want to say about this piece of paper right here. So again, this is like our prints, where there could be like a, level 1, level 2 in the basement or whatever, okay? And it would break down the whole area. Like it'll show like the kitchen, it'll show like the different bedrooms, and it'll show you all the different devices that you need, okay? Now, sometimes when it comes to a piece of equipment, such as, let's say, this light, you're gonna see something many times like LD1, and you're gonna be like, well, what does that mean? So many times for that particular home or for that particular job site, the engineer has approved certain equipment for that job. In other words, they know exactly how much wattage those different lights are, actually pull for the whole building. And so what we do is we go to the site specs, or what's called like a data sheet. So in other words, if we want to learn more information about this particular light or particular piece of equipment, for example, when I just said about, does that piece of equipment need a neutral? because you cannot fully look at a panel schedule and know how many wires a range needs, okay? Because many times we do need a neutral with a range or with a dryer because there are electronics that need 120 as well. And you know, they have lights and different things like that. So many times we need the neutral, and you cannot tell that information off of just the panel schedule, okay? So you have to look at your other prints. So in other words, sometimes you can be looking at the little designation above the light or above the dryer, above the oven or range, whatever you want to call it. And then you go to your site specs, and in here it'll tell you everything pertaining to that piece of equipment. It'll tell you like the size of the piece of equipment, how much wattage it takes, and everything. Because sometimes when it comes into the rough-in stage, and so the rough-in stage is before drywall, okay? And in order for insulation and drywall to happen, we have to pass inspection. That's what makes electrical very unique, in a sense that if the drywaller is trying to rush you, you don't have to get rushed. You can say, hey, you're not allowed to put your drywall up until I'm done, and until it's passed, okay? So when it comes to roughing in, sometimes, let's say for this light, if this is a fan box, or if it is a special kind of light that requires heavy supports, or if it's a really unique light where it has some type of weird installation that you've never seen before, that is where you're going to be going to like these site specs, and many times it's going to give you some information about what's going on for that piece of equipment, okay? All right, so some other things that you're going to need is, these are what's called like 4040s, that's what I've always called them. Or 4004s. So as you can see, this right here, you know, these are all the different sizes of wires that it's capable of, you know, you're allowed to put into them. So again, this is like a 14.2, and you can see 14.2 is right there. So it is allowed, right? So again, these are 4040s. These go into like metal boxes and stuff like that. What makes these plastic boxes so awesome for homes is you use these, right? So, and you only put one wire in each one, okay? But you just put them in there, and that's it, okay? That is your type of connector in these single boxes. But when you are starting to get into metal boxes, it gets a little bit trickier, because now you're going to need different types of connectors. Like for example, if you are using metal wire or armored wire, you're going to be having to use these, okay? And then in addition to your metal wire, you also need to use what's called anti-shorts, all right? So with electrical, there are lots of little fine pieces as you go along the way, okay? But typically in a residential setting, we are just kind of working with plastic boxes, which is awesome because it's very easy, right? We just run our wire, you strip the wire, you put it in, you make sure to bond the wire for safety. If you are putting your wires into a metal box, such as your actual panel, you're gonna need quite a few of these. And then when it comes to your range or your oven, you're gonna need bigger ones because it is a bigger size wire. And these nowadays can actually be put in either way. So for example, you can put it at like the top of the box or the bottom of the box. I'm not going to go too much into that in this video, but so essentially when it comes to a roughing in material list, you are going to be wanting to look at your panel schedule. That's the first place to start, okay? Your panel schedule breaks down all your different circuits for that particular home or typical suite in a condo. And then, you know, if you are in a condo, you just look at this and then multiply it by pretty much how many units there are. But you got to be careful because each unit can even be different within a condo on the same floor. Because in a condo, there could be like suite A, suite B, suite C, and it might be like a 1-bedroom, 2-bedroom, 3-bedroom. Obviously, with 3 bedrooms, going to have more circuits. So you as the boss, you just got to be careful. You can't just assume, right? But yeah, so this is the first place you start. These are what's called our home runs. In other words, we need to run from the panel to the actual piece of equipment, wherever it is on the job site or in the home. That's called your home run. And when it comes to certain pieces of equipment, for example, like let's say like a dryer, well, we're not jumping off the dryer and going anywhere else. Like it's simply just what's called like a dedicated home run. It comes from this panel to the dryer, you make your splices in the box, the dryer plugs in, it's done. Same thing with like the range or the oven. We just run our 8-3 to this range, we splice it in the box, it's a done deal. But when it comes to our other components, for example, let's say lights, well, typically it's not just one light on that circuit. There's going to be many lights. So the home run, typically you do want to run to the light switch. You do not want to be running power to the lights. And I already did another video about that. And in simple terms, it's always easiest to troubleshoot from the switch because you don't need a ladder, because you got to think like, so if we're just in the rough-in stage right now, well, typically there's no power. There is no devices on any of these boxes, all right? But when we are actually finishing and now all the lights are on, all the devices are on, if you have brought power up to the light, now you have to go get a ladder, you have to take down the light, and it's just way more involved. If you just brought power to the switch, and then from the switch, now you're going to jump to the other switch, and then when you want the light to work, then you run what's called a switch leg. So this right here would be called a switch leg. You just run a switch leg up to this light, and then if there's multiple lights off of that switch, you just jump off of the light now, okay? So we're not bringing power up to the light, you bring power to the switch. That is a pro tip. It's gonna help your troubleshooting way easier, okay? But again, so we are running a home run to a single device. So for example, let's just say like lights right here, you know, how many devices are on that particular circuit? And that's something you also have to keep in mind. So typically the code rule was always saying no more than 12 devices, but I'm always really sketchy when it comes to code because see, the thing is with code is it always changes. And so I don't really like to give specific numbers. Always ask your inspector and your most recent code. That's what you as electricians should be knowing out there. But this general information will help you out, okay? So for example, something like the fridge, well, you're not going to be splicing off of the fridge. The fridge is going to get that dedicated home run. And then, so for example, imagine this was like the fridge right here. Well, that's the fridge. We're not going to be doing branch circuitry around, okay? But if it's just a basic plug, as you can see right here, let's say number 3, circuit 3, it's general plugs. So which means that we're going to run a dedicated home run right here. And then from there, well, however many circuits are off of that. So 1, 2, 3, 4. So we have 4 devices on that one circuit. We bring the home run. Now, when it comes to actually running your wires, you know, some people, what they would do is they'll run one wire here and one wire there. But what's going to happen is now you have 1, 2, and then 3. So you actually have 3 wires in this box. And sometimes it could just be annoying for splicing, especially in a commercial setting. So that's one difference between a residential setting and commercial. A residential setting, everything's in number 14. And number 14 is typically really easy to work with our hands, okay? Once you start going up to number 12, it's a little bit bigger. It's still workable with, but once you start getting more wires in there, so for example, here in Canada, typically we splice on what's called a pigtail onto that plug. So this is how it would work. We'd have our home run coming in, that's 1 wire. We would have a, you know, so if we want to daisy chain or run our branch circuitry, so we have our home run, that's 1 wire. We come here, that's now 2 wires in there. If we went from here as well, that's 3 wires. And then we have a pigtail. So that would be 4 wires underneath one of these barrettes. And that's something I was going to talk about in just a second. Okay, so that's 4 wires underneath one barrette in a number 12, let's say, setting, which would be quite hard to all fit in that box. So in other words, you want to think ahead and be like, okay, well, wait, I can run a home run here, okay, just to this plug. Then we can run it here, here, and here. So really, we just eliminated 1 wire, makes the splicing a lot easier, okay? That is kind of like an apprentice to a journeyman. A journeyman has learned, and they like things simple, okay? You know, typically working in the lazy way is easier. You think ahead and you say, okay, I don't want to splice that many wires on my hands. Because as you start getting older, right, you know, as an electrician, you are going to get a lot of, you are going to get a lot of strength in your thumb and in your wrist because you're going to have to be clamping down a lot, right? But if you can ease the burden and just make it easy on yourself, that's going to make your actual splicing easier, okay? Because when it comes to the roughing in this video, I'm just talking to you about your material list. But the next part of roughing in is cutting in those wires, splicing them, and then pushing them in the back of the box so that the drywallers don't hit them, okay? And that's called like cutting in, okay? So there's like the material list of doing what's called boxing. We put these on the studs. And then once we put all our wires in, then we are going to splice our wires. And these are called barrettes. Now, don't be fooled when they say one size fits all. It doesn't, okay? That's just marketing. There are different sizes and there's different styles of morettes, okay? So that's something that you want to be looking at. You can just pause the video, you can look at this. But in other words, they're just saying that like this one little moret can fit like tons and tons of wires. But it's not true, because what will happen is you're going to stretch the plastic and it's just not as enjoyable. Sometimes you just want to go to a bigger moret size or a bigger, so technically these are called a wire nut, right? But a lot of times on the job site, we just call them morettes. Okay, so for your roughing in material list, a quick recap. Go through your actual home runs. You're going to have to figure out how many circuit breakers you're going to need. Okay, you're going to need to figure out how many of them are what's called arc fault and how many of them you can get away with just regular, because the regular breakers are way more affordable than an arc fault. Again, the arc fault is just kind of like a new trend. And sometimes there's even been times where the inspector, because it'll always trip on certain devices, things like a fridge or like a microwave. Many times these regular breakers we can use for those certain devices. So again, the electrical industry, it's a great trade. There's a lot of kind of politics, a lot of code rules, but you have to follow them in order to pass, okay? But the best way for you to pass your electrical rough-in is to work with the inspector, okay? So you look at the panel schedule. This is going to tell you the home runs. Not all home runs have branch circuitry. Okay, now many of them will. So again, like your lights and general plugs, these will have, you will be splicing on. But many times something like a fridge, microwave, range, dryer, these are just dedicated home runs. There is no additional splicing. The next thing you are going to be looking at is the general prints for electricals, okay? And you just count all the different devices that you're going to need to get an idea of how many boxes, how much wire are you going to need, and then also for the finishing stage, as you can see. So in this case, we have a single switch, okay? We also have a single plug. This box, so let's just say we would need one here, and we would also need one single gang here. But when it comes to the finishing stage, you would need a 15 amp plug and a single switch, even though it's using the same box, okay? We just screw it into there. So those are just the things that you have to look at when it comes to now the finishing, which is after roughing in. So I hope this video helps you in a sense of understanding a roughing in material list. You look at essentially your home runs. This is going to tell you all the different styles of wire you're going to need. And then what you want to do is go out into the field. In other words, look at the job site and figure out how much, for example, like if it comes to 8.3, see 8.3 is going to be very expensive compared to number 14. And so when it comes to 8.3, it's like you do not want to be buying way extra wire. Like you want to try to get it within the ballpark, and then whatever your measurement is, typically you add about 10%, okay? Because you never want the wire short. So that's what I'm saying. You look at this panel schedule. It tells you the wire types. It's going to tell you your breakers, which is also expensive. And then you go out into the field and you kind of figure out, okay, yeah, we're going to need this much of 8.3. We're going to need maybe 3 rolls of 14.3 or maybe 4 rolls. How much 12.2 are you going to need for your kitchen counter plugs? Your dryer, which would be 10.3 because it does have a light bulb in there, also electronics. So even though the dryer could be 208 or 240, some of the components are actually using 120. So I assume that it's taking either like the A phase or B phase and using that neutral. Okay. Those are things that like they don't teach you in school, but that's kind of how like these electronics work. But that's going to help you out tons, okay? And so again, that's the rough-in stage. And you as the electrician, you get out there, you install all your boxes, you drill your holes, you run your wires, you run your home runs. And then once you're all done, the rough-in stage, and again, you want to cut in your wires, then you call for inspection, okay? The inspector will come out, they will check your work. If everything is good, then the insulators and drywallers can get to work. But until that you have passed, they are not allowed. And if they try to rush you, if they try and go ahead, that inspector can make them rip out all their work, okay? So don't be rushed. And that's it. So hope you guys liked this video. Check out the website for more articles and leave comments below if you have specific questions, because more videos will be coming soon. And again, don't forget about my free book. If you want to download it, just go to becominganelectrician.com/subscribe. It's going to help you become a better apprentice electrician. You can get it totally for free, and you can stay updated with the website when I release new videos and articles. I'll talk to you in the next one.